Welcome, educators. Thank you for joining me in this session titled Building a Solid Foundation in Elementary Math Skills. My students are having so much trouble memorizing their multiplication tables and learning how to divide using long division. How can I help them develop their speed and accuracy in addition, subtraction, multiplication, and division? I am blessed to share with you some tools for building a good foundation in numbers, how to build speed in number facts, how to use a number line to visualize math concepts, how to effectively use math flashcards and manipulatives, some fun math facts to make math fun and interesting. May this session be a blessing to you. Math is such an important subject. After all, it's listed as one of the great 3 R's of a quality education: reading, writing, and arithmetic. Okay, maybe our word building should be included in there. The very first words of the Bible, in the beginning, are mathematical. That was the starting point of creation. 0 on the number line. Now, that was not the beginning of God or eternity. God and eternity have no beginning or ending. It was the beginning of creation. Then, in an orderly, creative fashion, God created light on the first day, a firmament on the second day, earth and the seas on the third day. Then he created the sun, the moon, the stars on the 4th day, and the birds and fish on the 5th day. On the 6th day he created the beasts of the field and cattle and everything that creepeth upon the earth. On that same day he created man in his own image. And God blessed them, and God said unto them, Be fruitful and multiply. Now, if that isn't math, I don't know what is. Then on the 7th day, God ended his work which he had made and rested. In the first 2 chapters of the Bible, we see that God is creative, orderly, and truthful. 3 very important character traits that are designed to show us the foundations of elementary math skills. In Galatians 4 and 5, we read, But when the fullness of the time was come, God sent forth his Son, made of a woman, made under the law, to redeem them that were under the law, that we might receive the adoption of sons. God's timing is always right. He sent his Son to die for us at the right time in history. It shows us that he is punctual, committed, and wise. 3 more of those 90 character traits of Christ that we want to develop into our lives and into the lives of the young people in our learning centers. These also are important in the development of math skills. Math skills are related to godly character. Math skills are built upon a foundation. There is no sense trying to teach a child algebra if he doesn't know how to add or multiply. I once had a family who wanted to enroll their 3rd grade daughter in our school. During the initial interview, the mother proceeded to let me know how advanced her daughter was. She doesn't need diagnostic testing. She had a really good math teacher in 2nd grade at her previous school. As a matter of fact, she was learning algebra in that class. Well, I looked over at the little girl and asked, What is 6 plus 7? I saw her hide her fingers under the table. And several seconds later, she finally said, 13. She could figure out her addition facts, but she certainly didn't know them with confidence. I said to this mother, as I have said to many others, there is no sense trying to teach children algebra if they don't have their basic math facts mastered. It will simply lead to frustration. So how do we get started in building this foundation? God started in the 1st chapter of Genesis with the counting of days. Psalm 90 verse 12 says, "So teach us to number our days, that we may apply our hearts unto wisdom." I think it's a great idea to build a math kit for your learning center. You can find some good suggestions for building a math kit on the A.C.E. School of Tomorrow website. On the home page, scroll all the way down to the bottom of the page and select Resources. Now scroll down to Curricula and you will see the link for building a math kit. In addition to the items mentioned, it is a good idea to also add flashcards, protractors, compasses, and any other upper-level math tools. Most of the items listed are manipulatives used to visualize how to count, add, and subtract. Some children use their fingers, but I don't recommend keeping their fingers in the math kit. We want children to be able to visualize the concepts of addition, subtraction, multiplication, and division. But eventually, we want them to know their basic math facts automatically without the use of manipulatives. I know many adults who still use their fingers to add and subtract. That is why we must practice, practice, practice. Let's talk about counting. Teach your children to count out loud. I had a friend whose 3-year-old knew how to count all the way to 100. It was so amazing and so annoying. He kept counting out loud all the time. But when that child graduated from high school, he was offered a full scholarship to the engineering department of our local university. I don't know if that's because he was such a good counter, but it happened. Counting objects is a great way to build a solid foundation in math. It is good for parents to teach their children to start counting objects out loud as soon as they can speak. When they are playing with their toys, put 2 in front of them, point to them, or pick them up one at a time and say 1, 2. How many toys? 2 toys. Then do it with 3 objects, then 4, then 5. After learning to count them, put the objects on the table and ask how many there are. Put some blocks on the table in piles of 1, 2, and 3. Ask which pile has 3 blocks, which pile has 1 block, and have them give you the answer. As your children learn to count objects, make sure they understand that one number corresponds to one object. Don't allow them to say the numbers faster than they point to or pick up that object. Teach them to count by 2s, 5s, and 10s also. This will help them in their multiplication and division later on. Let's talk about writing numbers. Teach your children to form their numbers correctly. I love the tracing and coloring exercises in the kindergarten math paces. They help develop their motor skills for forming their numbers correctly. They are taught the correct way to form each numeral in paces 1001 and 1002. Each number is formed inside a box. This makes it easy to know where to start the number. Please make sure that your students form their numbers from the top. Do not start any numbers from the bottom. Only for the numbers 4 and 5 do we lift our pencil to make a second stroke. Make sure your students are consistently forming their numbers correctly. Let's talk about addition. Addition is simply the combining and counting of objects. The numbers being added are called add-ins, and the total number of objects is called the sum. If you have 1 block and then you add another to it, well, I now have 2 blocks. Adding 1 is simply stating the number that comes after the given number. When I add 1 to 7, the sum of the 2 numbers is the number right after 7, which is 8. In the first and second level math paces, students are to ask their supervisor for blocks or sticks from the math kit. See Math Pace 1003 on page 7. The purpose of this is for them to visualize the concept of adding. Then they are told to return their math kit and practice some addition facts. We want the students to try to do these without the use of those manipulatives if at all possible. If they struggle with this, practice with them orally. We want to get them away from relying on the manipulatives. A number line is also a great visual tool. If we are to add 7 plus 2, we can jump from 0 to 7 on the number line and then make 2 more single jumps to the right to get to 9. Therefore, 7 plus 2 equals 9. One of the properties of addition is that it is commutative. That means the order of the add-ins does not matter. The sum will still be the same. 7 plus 2 equals 9, just as 2 plus 7 equals 9. On the second level math paces, beginning with pace 1016 on page 9, there are some oral addition problems. In the next several levels, there will be similar pages for subtraction, multiplication, and division. These pages are very important. If a child cannot recite the answers in the allotted time, be sure to give him extra drill. Put a note on your goal check report to remind you to practice those facts every day until he can recite them in the allotted time. An excellent tool for mastering the addition facts is Math Builder on the A.C.E. Connect platform. You can select the number of problems to attempt and the amount of time to solve them. Then have them practice every day until they can master all the single-digit addition facts. Even if you don't have access to A.C.E. Connect, you can make addition math fact tables to practice with your students. This will build speed and accuracy if you practice with them just a little bit every day. Tables that I'm showing you today are available as a free download in the description below. Look at the column that has the plus ones. Time your students with a stopwatch as they say the answers. Have them practice until they can do it in 10 seconds or less. If they have trouble, remind them that plus 1 means the number that comes after. After mastering the plus 1 column, do the same for the plus 2 column, and so on until they can do each column in 10 seconds or less. By the way, they won't be able to do them in 10 seconds if they're using their fingers to add them up. Give them a prize when they have mastered the whole sheet. Let me give you an example. If you look over at the plus 3 column, just ask them to say it like this. Say, just give me the answer only, and then you can point to the number and have them give you the answer for each of those problems. For instance, on the plus 3 column, the students would just say 4, 7, 10, 13, 6, 9, 12, 5, 8, 11. And that's how you would do the addition math fact sheets. Addition flashcards are also very helpful in building speed and accuracy in basic addition math facts. Let's talk about subtraction. Subtraction is the opposite of addition. It is simply addition in reverse. Rather than combining objects, we are removing or taking away objects from a group. The answer in a subtraction problem is called the difference. The first number, the one we are subtracting from, is called the minuend. The number that is being subtracted is called the subtrahend. On the number line, we start at the point of the menu end, the first number, then we count back to the left, the number the number being subtracted, the subtrahend. For the problem 8 minus 5, we find 8 on the number line, then count back 5 spaces to the left. We are now at 3 on the number line. 8 minus 5 equals 3. If I have 5 blocks and I subtract or remove or take away 1 block, I now have 4 blocks. Subtracting 1 is simply stating the number that comes before the given number. Subtraction is not commutative. You cannot switch the order of the menu end and the subtrahend and expect to get the same answer. 8 minus 3 will not give the same answer as 3 minus 8. In elementary math, the larger number must always be first. It must always be the menu end. Use Math Builder on the A.C.E. Connect platform to practice for speed and accuracy in subtraction. And then again, use the subtraction math facts tables to practice just as you did with the addition. It won't hurt to practice the +1 tables and then the -1 tables, then the +2 tables, followed by the -2 tables, and so on. Now let's talk about multiplication. Multiplication is repeated addition of groups of equal sizes. The number of groups, the first number, is called the multiplier. And the number of objects in the group, the second number, is called the multiplicand. The answer in a multiplication problem is called the product. Multiplication is also commutative, which means the order of the numbers being multiplied does not matter. 3 times 4 equals 12, just as 4 times 3 equals 12. In multiplication, we are often using larger numbers. The manipulatives are still helpful for visualizing the multiplication concept, but we don't want the children to count all those sticks. We want our students to understand that 7 times 8 means that we have 7 piles of 8 objects, but we don't want them to count all the way up to 56. Adding 8 7 times is faster than counting sticks, but it is best if they memorize the multiplication tables with much practice. The same is true for the number line. We want them to visualize that 2 times 3, that means that we are jumping 3 spaces 2 times. But for 9 times 6, you would have to have a very long number line. It is best for them to memorize these tables. Again, let me encourage you to use the Math Builder program on the A.C.E. Connect platform to practice for speed and accuracy. Use the multiplication math facts tables to practice just as you did with the addition and subtraction. They should be able to do each column in 10 seconds or less. Using a multiplication chart helps students to see that most of the multiplication tables are easy to learn. If they know how to count, then the ones tables are very easy. Anything multiplied by 1 is the same number. If they learn to count by 2s, then the second row and the second column will also be easy to fill in. Counting by 5s and 10s allows them to fill in those rows and columns. A fun fact in multiplying by 10 is that we just put a 0 after the number we are multiplying. This is even true with large numbers. 38 times 10 equals 380. Then it is good to memorize the squares, the numbers multiplied by themselves, such as 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, and 9 times 9. Doesn't even hurt for them to learn 11 times 11 and 12 times 12. Well, now after they learn their 3s and 4s, there are only a few facts left to master. 7 times 6, 8 times 6, 9 times 6, 8 times 7, 9 times 7, and 9 times 8. The 9s are also quite easy to learn. Notice these fun facts about the 9s. All the multiples of 9 have digits that add up to 9. 1 times 9 equals 9. 2 times 9 equals 18. Look at the 18. The 1 plus the 8 makes 9. 3 times 9 equals 27. The 2 plus the 7 makes 9. 4 times 9 equals 36. The 3 plus the 6 equals 9. All of them add up to 9. Notice that starting at 2 times 9, the first digit in the answer is 1. And as you go down the list, the numbers are in consecutive order from 1 to 9. Then the second digit going up is in consecutive order going up from 0 to 9. Notice that the first number is 1 less than the number you are multiplying. For 3 times 9, the first number is 2. For 7 times 9, the first number is 6. Then the second number in the answer is just 9 minus that first number. If they have learned the subtraction tables well, the 9s are very easy to learn. Here is a good way to visualize it. Let's take 6 times 9, for example. First, we subtract 1 from the 6 to get 5. Then we subtract from that 5 from 9 to get 4. That gives us the answer 54. Try it with 4 times 9. First, subtract 1 from the 4 to get 3. Then we subtract that 3 from 9 to get 6. That gives us the answer 36. This even works with large numbers. What is 8 times 99? Subtract 1 from the 8 to get 7. Then subtract that 7 from 99 to get 92. That gives us the answer 792. Try 645 times 999. Subtract 1 from the 645 to get 644. Then subtract 644 from the 999 to get 355. That gives us the answer 644,355. Aren't the 9s fun? Here are some fun facts about multiplying by 11. When multiplying a single digit by 11, we simply write that digit twice. 4 times 11 equals 44. 7 times 11 equals 77. For two-digit numbers, I like to say it like this. Put a space between the two digits and put their sum in that space. So if I have 23 times 11, I open up the 2 and the 3 and put a space in there, and then I take the sum of 2 and 3, which is 5, and put it in the middle. 23 times 11 is 253. Look at 71 times 11. I open up the 7 and the 1, put a space in the middle, and add the 7 and the 1, gives me 8, and I put that in the middle. See if you can solve these next few problems on the screen. 36 times 11, 11 times 11, and 44 times 11. Did you get them all? Here's the answers. 36 times 11 equals 396. 11 times 11 equals 121. And 44 times 11 equals 484. However, if the sum of the two digits is 10 or more, we have to carry the 1 to the hundreds place. For instance, if I have 48 times 11, I still do the same thing. I separate the 4 and the 8, and then I add 4 plus 8 and put a 12 in the middle. But that 1 I have to carry over to the 4 and make it a 5. So my answer is 528. Look at 75 times 11. I separate the 7 and the 5 and add them together and put 12. I'll carry that 1, adding it to the 7. It makes 825. It takes some practice to do these in your head if the digits add up to 10 or more. See if you can solve these. 99 times 11 and 65 times 11. Did you get it? Here's the answers. 99 times 11 is 1,089. 65 times 11 is 715. Division. Division is the opposite of multiplication. It is the method of grouping things into equal parts. The number that is being divided is called the dividend. The number by which the dividend is being divided is called the divisor. The answer to a division problem is called the quotient. Sometimes we cannot divide things exactly and we might have a leftover number. That leftover number is called the remainder. Division is not commutative. The order of the dividend and the divisor matters. 6 divided by 2 is not the same as 2 divided by 6. There are several different ways to express division. We often see division expressed in a single line like we showed above. 6 divided by 2 equals 3. This same problem can also be expressed like this. 6 divided by 2 equals 3. Or also as a fraction like this. 6 divided by 2 equals 3. In each of these expressions, 6 is the dividend, 2 is the divisor, and 3 is the quotient. When expressing the problem as a fraction, it is better to say 6 divided by 2 is equal to 3 rather than 6 over 2 equals 3. Use the manipulatives to help your students visualize the grouping that takes place in division. Take 12 blocks or sticks and give one to A.C., one to Christy, and one to Racer, like this. Pass one out to Racer, one out to Christy, one out to A.C., and just keep passing them out until all of them have been passed out. Once you have passed out all 12 of those, you will notice that there are 3 groups of people that have some blocks in front of them, and each of them has 4 blocks. There are 4 in each group. We have just illustrated that 12 divided by 3 equals 4. The manipulatives are helpful for visualizing the division concept, but we don't want the children to count all those sticks or all those blocks. We want the children to understand that 63 divided by 7 equals 9 means that if we have 63 sticks or blocks and make 7 groups of them, there will be 9 in each group. But we don't want them to have to count all those sticks. It is much better and much faster to learn their division facts. Have your students practice the division facts on the Math Builder program of the A.C.E. Connect platform to practice for speed and accuracy. I think it is best to master the multiplication tables before working on the division tables. Division is much easier after they know their multiplication. Use the division math facts tables to practice just as you did with addition, subtraction, and multiplication. They should be able to do each column in 10 seconds or less. These math facts tables are just something I made up myself to give extra oral drill. You can even cut them up into groups, laminate them, and save them in your math kit. I found them to be very helpful. The key to learning the basic math facts is practice, practice, practice. Remember, these math facts tables are available for you to download in the description below. Let's talk a little bit about neatness. Earlier, I expressed the importance of forming the numbers correctly. It is important that the numbers are legible and lined up neatly. In working with students in higher levels of mathematics, I have found that most mistakes are not because of difficult calculations, but rather because of mistakes in basic arithmetic calculations. And I have found that most mistakes in arithmetic calculations are because of a lack of neatness. When students are learning to add or subtract numbers that have several digits, it is very important that they line up their numbers neatly. Let me give you an example. If I was to add 345 plus 512, I want to make sure that the numbers are lined up directly underneath one another. That way I can add them up. 5 plus 2 equals 7, 4 plus 1 equals 5, 3 plus 5 equals 8, and I get an answer of 857. However, what happens if I don't line the numbers up correctly? Well, take a look at this. If I have 345 plus 512 and they're not lined up underneath each other, I might add it like this. 2 plus nothing is 2. 5 plus 1 is 6, 4 plus 5 equals 9, 3 plus nothing equals 3, and I might say 345 plus 512 is 3,962. Wouldn't that be confusing? The same is true in multiplication. We want to make sure that our numbers are lined up correctly. For instance, if I have 23 times 45, I want to make sure that my 4 and 5 are directly underneath the 2 and the 3. So when I go to multiply, I multiply 3 times 5 makes 15, carry the 1. 2 times 5 is 10, plus the 1 is 11. Then I put a 0 in there to fill the 1's space. I'm going to be doing 3 times 4 equals 12. I write the 2 there, carry the 1. 4 times 2 is 8, plus the 1 makes 9, making sure that they are lined up neatly. I add these together. 5 plus 0 equals 5, 1 plus 2 equals 3, and 1 plus 9 equals 10, giving me an answer of 1,035. However, if I don't line up my numbers correctly, I might do it like this. 23 times 45, I would multiply the 3 times 5 and get 15. The 2 times 5 equals 10, plus the 1 I carried makes 11. But if I don't put a space in there and do 3 times 4 equals 12 and put the 2 way over there, it's going to throw everything off. 2 times 4 is 8, plus the 1 I carry makes 9. 5 plus 2 is 7. 1 plus 9 is 10. Carry the 1. 1 plus 1 is 2. That would give me an answer of 207, which is incorrect. Be sure to hold the place value in the correct spot or position. In long division, it is very important to write neatly and line up each number directly underneath the other numbers. Let's say, for example, I have 438 divided by 6. Well, how do I go about doing this? Well, since 6 is greater than 4, I can't divide 4 divided by 6, so I go to the second digit. I'm going to ask, what's 43 divided by 6? Well, I know that 6 times 7 is 42, but I want to make sure that I put it right above the 3 because it's 6 times 7 is 42. I'm going into the first 2 digits. So now I multiply. 7 times 6 is 42. Make sure that I put it directly underneath those numbers. And then I'm going to subtract. When I subtract this, I get a 1. And then I bring down the next number, which is an 8. And I do the same thing now. I will divide. 18 divided by 6 is 3. I place it right next to the 7, directly above that 8, and multiply. 6 times 3 is 18. I subtract. I get 0. There is no remainder, and there's no more numbers to bring down, so my final answer is 73. Placing your numbers in the correct position and writing neatly is so important. Now let's talk about having some fun with math. Be sure to make math fun and interesting for your students. If they can see that you don't enjoy math and tell them things like, you're never going to need this in life, they are going to develop a dislike for math also and will struggle with math concepts throughout their school years. Play math games and have math races. Show them some fun math tricks such as multiplying by 9s and 11s like we did earlier. I always enjoyed teaching the following math trick to my students and then telling them to go home and astound their parents. I would write a random 5-digit number on the whiteboard, perhaps 47,238. Then I would ask them to give me a random 5-digit number. They might give me something like 71,056. Then I would pick another 5-digit number, but this time I would make sure that the digits I picked under their number added up to 9. So I would pick 2 because 7 plus 2 is 9, 8 because 1 plus 8 is 9, 0 plus 9 is 9, then 4 because 5 plus 4 is 9, and 3 because 6 plus 3 is 9. Then I would do it again. They might give me the number 63,751. So I would pick numbers that add up to 9, 36,248. Notice each digit adds up to 9, making sure that the digits add up to 9. With all those numbers written on the board, I would ask, what is the sum of those numbers? 47,238, 71,056, 28,943, 63,751, 36,248, and I would give them the answer before they even got their calculators out. How did I know the answer? Well, here's how I did it. Since they gave me 2 5-digit numbers, the first number was going to be a 2. Then I wrote that original first number and subtracted 2 from the final digit. This is a trick using the 9s. It's amazing. It's even amazing with your staff and your parents at open house. Practice it. Try it a few times. You'll have a lot of fun with it. Here is another amazing math fact. Can you catch the following patterns? Watch this. 1 times 1 equals 1. 11 times 11 equals 121. And then 111 times 111, look at the pattern. There's 3 1s on each side. It goes like this. 1, 2, 3, 2, 1. Look what happens if I have 4 11s, or 4 1s times 4 1s. When I multiply those together, it comes up to 1, 2, 3, 4, 3, 2, 1. What do you think you would get if you had 9 1s times 9 1s? Well, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. Here's another fun math fact with the 9s. Can you catch the following pattern here? 1 times 9 plus 2 equals 11. 12 times 9 plus 3 equals 111. 1, 2, 3 times 9 plus 4 equals 1111. 1, 2, 3, 4 times 9 plus 5 equals 11111. Can you imagine what it would be if I had 1, 2, 3, 4, 5, 6, 7, 8, 9 times 9 plus 10? Well, I'd have 10 ones right there in a row. Here is a math fact that I have often found useful in high school levels of math. When squaring a number that ends in 5, the last 2 digits of the answer will always be 25. And the first digits will be the product of the number that came before the 5 and that number plus 1. For instance, look at the pattern here. 5 times 5 is 25. But if I have 15 times 15, it's going to have a 25 at the end. And then the first digit is a 1. I multiply that by the number that comes after 1, 2, and it gives me 225. 25 times 25 equals 2 times 3, 6. 25. 35 times 35 equals 3 times 4, 12, 25. 85 times 85, 8 times 9, 72, then 25. Try it yourself. See what numbers you can come up with. Remember that in order to build a solid foundation in elementary math skills, our students should recognize that these skills are biblical, they can be fun, and they are developed with much practice, practice, practice. Thank you, and God bless you.